Okay, this question says, at Grand Annecy Beach, the height of water in meters is modelled by the function h of t is equal to p cos q times t plus r, where t is the number of hours after 2100 hours on the 10th of December 2017. The following diagram shows the graph of h for t is between 0 and 72. Then we've got our graph here. Alright, and it says point A, which is 6.250.6 represents the first low tide, and B, 12.5, 1.5 represents the next high tide. So question A, part 1 says how much time is there between the first low tide and the next high tide? So this is just a matter of reading it off from the graph. So this is a high tide here, this is a low tide, this is a high tide, low tide, high tide, low tide. So this is the first low tide, which gives us the time, the first point 6.25, and the next high tide is this one, 12.5. So we just need to do 12.5 minus 6.25, which equals 6.25 hours. Okay, then A part 2 says find the difference in height between the low tide and the high tide. So in exactly the same way, we just need to read off the difference between the low tide here, which the value is 0.6, and the high tide here, where the value is 1.5. So the difference is 1.5 minus 0.6, which is equal to 0.9 meters. Alright, next it says find the value of p. So if we remember, this function here was h of t is equal to p cos q times t plus r. So what we need to do here is find p. So p is going to be the amplitude of the function. So the amplitude, if you remember, is the height from the top to the centre. So the amplitude is this here. That's the amplitude, and that is going to equal p. So all I need to do then is that's going to be halfway between the difference between these two. So the difference here was 0.9, so p is going to be half of that, which is going to be 0.45. Right, next it's asking us to find q. Now for this kind of function, this is a cos wave here, so it's this q value in front of the t is equal to 2 pi over the time period. Okay, this is equal to 2 pi times the frequency, or 2 pi divided by the time period. This is just the way how these wave functions work. So this is sometimes referred to as omega, which is the angular velocity of the wave. So what we need to do is just do 2 pi divided by the time period. Now it had us work out the time period here, which was 6.25. So q is going to equal 2 pi divided by, that is the time between the first low tide and the next high tide, so that's actually half the time period. So it's going to be 2 times 6.25. So that's just going to be pi divided by 6.25, which I can then use my calculator, and I can say pi divided by 6.25 is equal to 0.503. 0.503. Okay, next it's r. So if we go back to the function again, function is here, and r is going to be the vertical translation. So if this was a regular cosine wave, this red line that I've drawn here would feature at 0. So it's the vertical shift from 0 to where this is here. So this value, instead of being at 0, is shifted up a certain amount here. And the amount it's going to be shifted up is going to be 0.6 plus, and then what this amplitude was, or it's going to be 1.5 minus a. So it's going to be 1.5 minus 0.45, which is going to equal 1.05. Okay, likewise I could have done 0.6 plus 0.45, which would give me the same thing. So QR is equal to 1.05. All right. Okay, so looking at part C, it says there are two high tides on the 12th of December 2017. At what time does the second high tide occur? So if we go back to our graph, we can see the high tides here. So this is the first high tide, second one, third one, fourth one, fifth one, sixth one, etc. We can also see that the first high tide here occurs, and it tells us 2100 hours on the 10th of December 2017. We can also see that the time between consecutive high tides is the time between 0 and 12.5 here. So it's every 12.5 hours. So starting at 2100 on the 10th of December, and then adding on 12.5 hours until we get to the second one on the 12th of December. So if we start with the first one, which is 2100 on the 10th, we can then go add 12.5 hours on, which will be 9:30 on the 11th. We can then add another 12.5 hours on, which will be 2200 on the 11th. We can then add 12.5 hours on again, which takes us to 10:30 on the 12th, which would be the first one on the 12th, and then finally add on another 10.5 hours, 12.5 hours, which would take us to 2300 on the 12th, and that would be the time for the second high tide to occur. 2300 hours on the 12th. This question says, random variable x is normally distributed with a mean of mu. In the following diagram, the shaded region between 9 and mu represents 30% of the distribution. So it's telling us here that this grey region here is 30%, or with a 0.3 probability. Then it says, find the probability that x is less than 9. So it wants to know what's the probability of this. So since we know that up until the mean will be 50%, because the mean is the centre, so up to here will be 0.5, this part will be 0.3, so this part would be 0.5, take away 0.3, which would be 0.2. Okay, next it tells us the standard deviation of x is 2.1, and it asks us to find the value of the mean. So what we're going to do here is we're going to use this equation here to help us, this one. So it's a standardized normal variable, and it says z is equal to x minus mu over sigma. I'm just going to write that down on the other page. Z is equal to x minus mu over minus mu. X is equal to z minus mu over sigma. Okay, so that's the equation we're going to use here. Now, using this information that we've got here, probability is less than 9 is 0.2. We can then look up the corresponding z value for this x value. So x is going to equal 9, and then we're going to find the z value from the table from our graphical calculator. Sigma we know is the standard deviation is 2.1, and then that will help us to work out what mu is. I can also rearrange the equation, so I can say that it's going to be mu is going to equal, I'll move that to that side, it's going to be x minus z sigma. So I can work out the corresponding z value from my graphical calculator or from some kind of lookup table, which I'm going to do. So when you have a probability of 0.2, the critical value is minus 0.8416. So z is equal to minus 0.8416, which you can get from your graphical calculator or some kind of lookup table of critical z values. You just look up the 0.2 here, and that will give you the minus 0.8416. Then I can stick this into this equation here, so I know what x is, which is 9, I know sigma, I know z, and then I can work out what mu is. So if I get my calculator out, it's going to be, so it's minus 0.8416 negative, multiply that by sigma, which is 2.1, and then we need to make that negative and add that to x, which is 9, which is going to give me 10.77. So mu is equal to 10.77. Alright, next it says the random variable y is distributed normally with a mean of lambda, standard deviation 3.5. The events x is greater than 9 and y is greater than 9 are independent, and the probability that x is greater than 9 intersected with y is greater than 9 is 0.4. And then it says to find lambda. So here what we need to do is understand what this means. So it means the probability of x being greater than 9 and the probability of y being greater than 9 is 0.4. So when you have two probabilities of independent events, what you do is you multiply this probability by this probability, and that gives us 0.4. So we can therefore say that the probability that we're looking for, probability of y being greater than 9, is going to equal 0.4 and then divided by the probability of x being greater than 9. So to work out what the probability of x being greater than 9 is, here we know the probability of x being less than 9 is 0.2. So the probability of x being greater than 9 would have to be 1 take away 0.2. So this would be 1 minus 0.2. So that would give us, if we work out that, that's going to give us 0.5. So then if the probability of y being greater than 9 is 0.5, probability of it being less than 9 would be 0.5, so that would mean that the 9 would be right in the centre, so that means that the mean would therefore be 9. So the mean is equal to 9. Alright, so that was part C. Next it says part D, it says given that y is greater than 9, find the probability y is less than 13. So we're going to have some work to do here. So what I'm going to do first of all is just draw in a little graph so we can see what's happening. So we're going to have our normal distribution like that. We know that the mean is 9, we've just worked that out, and then what we want to know here is the probability of it being in this region here between 9 and 13. So we're looking for this area here. Now we can use the same equation we had earlier up here, this one, z is equal to x minus mu over sigma. Since we know mu and we know sigma and we can use x, we can work out what the z value is. So what I'm going to do is work out the z value, use the z value, find the z value for this green area here. So we're going to find the probability of this. Okay, now we're going to do that by saying that the z for that region is going to be x minus mu over sigma. So it's going to be 13 minus 9 divided by 3.5, which is going to give us 1.143. I can then look up that z value and find the corresponding probability. So again, you can use your graphical calculator to this to turn z value into probability. So the probability for that is therefore going to be 0.127. So that means the probability of this green region here is going to be 0.127, and I can then take that away from 0.5 to find the probability of the red region. So the red region, probability of this one is going to be 0.5 minus 0.127, which is going to equal 0.5 minus 0.127, it was 0.373. Okay, now you can do that with your graphical calculator. There might be a way for you to just determine that value directly, but the way I've done it here is to work out the probability for this, work out the Z value for that, and then do a back lookup. Probability for this one and then probability for this region. Right, once we know the probability of it being within this region here, we can then say that says given that y is greater than 9, find the probability it's less than 13. So the probability it lies between 9 and 13 is this one, but we already know it's greater than 9, so we already know that it's within this 50%, so we can ignore this 50%. So we want to know what's the chance of it being 0.373 out of 0.5. So the answer will be, let's just write that, let's change my pen back to yellow. So, right, what have we got to do? So we got to work out the probability of y being less than 13 when y is greater than 9 is equal to 0.373 out of 0.5, which equals 0.373 divided by 0.5 equals 0.746. And that is the answer.